Welcome to Academy Math. In this video, I will solve question number 2 of exercise 2 of the book Higher Algebra by Mapa. There are five questions of question number 2, and in this question, we have to determine that a relation rho on S is reflexive, symmetric, or transitive. That is, we have to check rho on S is RST. And in the first question, rho is defined on S by, here S is given that set of all straight lines in a plane, all straight line in a plane, and for L M belongs to S, rho is defined as L is related to M if and only if L is perpendicular to M. To small m. Solution. We know that any line segment AB is not perpendicular to itself. This line AB is not perpendicular to itself. It can't be perpendicular to itself. Hence, L does not related to L for all L belongs to S. Therefore, rho is not reflexive. Second, let Lm belongs to S such that L is related to small m. Then L, small l, is perpendicular to small m, which implies that small m is perpendicular to small l, and which implies that m is also related to small l. Here we can conclude that L is not perpendicular to L, as or here L is not perpendicular to L, and therefore we can put that rho is not reflexive. But we can see here that rho is symmetric. Rho is a symmetric relation, as L is related to M implies that M is related to L, as L related to M implies that small m related to L. Hence we can conclude that the relation rho on S is symmetric. Now we will check is rho transitive or not. Let small l, small m, and small n belongs to S, that is, there are three lines in S. Now let small l is perpendicular to, let small l is related to small m, and small m is related to small n. We will check that small l is related to small n or not. We will check this. Our observation is small l is related to small l or not. Small l is related to small n or not. Now it is given that small l is related to small m, and therefore we can write it small l is perpendicular to small m and small m is perpendicular to small n, but which does not imply that small l is perpendicular to small n. In a plane, two lines are either intersecting or parallel. Either intersecting or parallel. That is, if two straight lines belongs to the same plane, let P and Q, and R and S are two straight lines. Suppose this is L and this is N. Then either they intersect or they parallel. If they intersect at 90-degree angle, then we say that the lines L and M are perpendicular. That is, in such cases where the angle between them is 90 degree. If it is happened that angle between L and M is 90 degree and M and N is also a 90-degree angle, if there exists another line and which is perpendicular to N, it will looks like that. And this line small n, this line can't be small n, and this line can't be perpendicular to this line. That is, it is not possible the perpendicularity of these two lines. That's why small l, this does not imply that small l is perpendicular to small n, and hence we can conclude that L related to small m and small m is related to small n does not imply that L is related to small n. Therefore, the given relation is not, therefore the given relation is not transitive. So finally we get it is not reflexive, it is symmetric, and it is not transitive. Therefore we get finally it is only symmetric relation. So this relation is only a symmetric relation. Thank you. Now I will solve the question number B of the question 2, that is in the next page. That is question number 2.B is given by S equals Z, that is the set of all integers, and rho is defined on S. Rho is defined on S by A is related to B if and only if A minus B is less than 3, or AB belongs to Z. We have to check out that is rho reflexive, symmetric, or transitive. Therefore, in the first step, let small a belongs to Z, and as small a minus small a equals 0 and which is always less than 3, therefore we can conclude that A is related to A for all A belongs to Z, which implies that rho is a reflexive relation. Is a reflexive relation. Let AB belongs to Z such that A is related to B, which implies that A minus B is less than 3, and which does not imply that B minus A is less than 3. Hence, A is related to B does not imply B is related to A, and therefore rho is not symmetric. Now we will check the last relation, that is the relation rho is transitive or not. Let ABC belongs to Z, that is Z, and which is equals to S also, such that A is related to B and B is related to C. That is, A minus B is less than 3 and B minus C is less than 3. But if we add these two equations, A minus B plus B minus C will less than 3 plus 3. That is, A minus C is less than 6. But which does not imply that A minus C is less than 3. Therefore, rho is therefore A is related to B and B is related to C does not imply that A is related to C. Therefore, rho is not a transitive relation. To verify the last, that is the transitivity, we will take an example. Suppose A equals 5 and B equals 3. Then A minus B is equals 5 minus 3 equals 2, and which is less than 3. That is, 5 is related to 3. That is, 5 is related to 3. And let C equals 1. Then B minus C equals 3 minus 1, which equals 2, and which is also less than 3. That is, 3 is related to 1. But is 1 related to 5? My question is that this 5 is related to 1 or not? Since 5 minus 3, which equals, sorry, this is 5 minus 1. Since A minus C equals 5 minus 1, which equals 4, and which is greater than 3. That is, we have observed that 5 is related to 3 and 5 is related to, and 3 is related to 1. Five is related to 3 and 3 is related to 1 does not imply that 5 is related to 1. Hence, therefore, rho is not transitive on S, and which is equals Z. Thank you. Now I will solve the last 3 questions of question number 2 in the next video.